So you are going to work on a lab today over titrations. And a titration is something that is frequently encountered in the laboratory, and all it is a laboratory technique used to determine the concentration of a particular solute. Now, with the titration, there are three main components. The first component is something called a standard solution, which is simply a reagent of a known concentration. The second component of a titration is a solution of unknown concentration. Now, the objective of the titration is to determine the unknown solution's concentration. So this one is key for that reason. Then finally, the last component that goes into a titration is something called an indicator. An indicator is simply a dye that changes color when the equivalence point is reached. I threw out a new term there, equivalence point. So let's define what equivalence point is. This is defined as the point at which the moles of solute equals the moles of solvent. Now, one of the most common titrations you will encounter in the laboratory is what's called an acid-base titration, which is what you will be performing today. In an acid-base titration, the equivalent point is reached when the moles of acid equals the moles of base. This is going to allow us to perform some of the calculations that involve these titrations. For example, here's a problem. What is the molarity of an NaOH solution of 48.0 milliliters? What is the molarity of an NaOH solution if, not of, 48.0 milliliters is needed to neutralize 35.0 milliliters of 0.144 molar H2SO. Try that again. H2SO4. Now, is that just a hair bigger? So, to start with this, we can use solution stoichiometry to determine this particular calculation. we're going to need to write out our balanced chemical equation. And here I'm going to switch to drawing. It's a little bit easier. So we have H2SO4, maybe, which is aqueous. And we are going to add that to NaOH. And this is going to give us the products of Na2SO4 plus water. Now we need to balance out all of our components here. This is not a balanced reaction. So we have 2 sodiums on the right, so we're going to need 2 sodiums on the left. Right here. And by doing this, we're going to need a 2 in front of the water. Let's see if I got a little room to balance it all out. Okay, so the first thing we're going to have to do is calculate. Try this again. Calculate the moles of H2SO4 that is required to reach the endpoint of this titration. So, if we have 0.144 moles H2SO4 per liter, we're going to multiply this times the volume, which is 0.0350 liters. And of course our liters are going to cancel out, and that's going to give us 0.00504 moles of H2SO4. And in long form, this is what that looks like. Okay, so we know from our balanced chemical reaction that for every 1 mole H2SO4, we have 2 moles of NaOH. So we can then take our moles H2SO4 and do some stoichiometry here. We got 2 moles NaOH per 1 mole H2SO4, and that's going to equal 0.01008 moles NaOH. In order to get the concentration of our sodium hydroxide, we need to divide it by our volume so that our sodium hydroxide solution, in this case, is we're going to divide that by our volume, which is 0.0480 liters, and that gives us 0.210 molar capital M there, NaOH, which is going to be the concentration of our unknown solution, in this case the sodium hydroxide. Usually when we perform titrations, you'll typically use a pipette and a burette because the volumes that we use are going to be very precise, and this allows us to calculate each of the concentrations of our unknown solutions. So today in the virtual lab, you're going to calculate the unknown concentration of a particular item.